Dear students, we are solving the IB Math AHL past paper questions, and currently we are solving the IB Math AHL May 2023 paper 2 time zone 2 past paper. Today we will be solving the last question, that is the question number 12 of this paper. You will be getting the links to the previously solved questions of this paper and of the other papers in form of playlists in my channel NS Online Math Tutoring Classes. I am Nilanjana Sanyal. I am an online math tutor. I tutor students from the AHL stream. In case you are interested in joining my classes, please contact me for more details. So without any further delay, let us start answering question number 12. The maximum mark is 21. It says consider the differential equation dy by dx equal to x squared plus 3y squared over xy, where x is greater than 0 and y is greater than 0. It is given that y is equal to 2 when x equal to 1. Part A's question is use the Euler's method with step length 0.1 to find an approximate value of y when x equal to 1.1. It is containing 2 marks. And you will be having the two formulas that you require for using the Euler's method in your formula booklet. But what I write is for the case of x, in the formula booklet it is written xn plus 1. I will be writing xc. You can write xn plus 1, no harm. Okay. Xc is equal to xp plus the step length, which is h, which is 0.1 in our case, and the y, current value of y, is equal to the previous value of y plus the step length times the function expression, which is the gradient function expression, and which is a function of both the previous value of x and the previous value of y. These two are the formulas given in your formula booklet. Okay, we will be using these in order to get the value of y when x equal to 1.1. It is just an approximation. Euler's method, through Euler's method, we don't get the accurate answer, we get just an approximate value of y. Okay, and we will be, of course, using the calculator. So let us go to the calculator. I am using the TI Inspired calculator. You can use the Casio calculator as well. So add list and spreadsheet. I go to add list and spreadsheet, and I can name this as x and this as y. It is not essential, but you may name the columns, okay? Because the A column will be containing all the x values and the B column will be containing all the y values. Next, we will be writing in the first row, we will be writing the initial given values of x and y. And the given value of x is 1, so I'll be writing 1 over here, and I'll be moving to this cell. This is the given value of y when x equal to 1, which is equal to 2. Fine, so I come over here. Okay, so now I will be calculating the current value of x based on the previous value of x, which is stored in the A1 cell. So I will be using a formula, and the formula always starts with the equal to sign. So I will be writing equal to sign, and x previous, it is, you see, the formula is x previous plus h. X previous is the previous value of x, which is stored in A1 cell. So this is A1 plus the step length is 0.1. So it is 0.1. Enter. 1 plus 0.1 is indeed equal to 1.1, and we need the value of y when x equal to 1.1. So I really do not need to bring it down, but I'm just showing you the method in order to get more number of x values. But for this question, you really do not need to bring this down. 1.1 is sufficient. Okay, and I come to this, and again I will be getting the corresponding y value. The formula that I'll be using is this one. Yp is stored in the B1 cell. Okay, and f is the gradient function, and in place of x is xe. So in place of x, I'll be writing a1, and y is yp. So in place of y, I will be writing b1. Okay, so I go to this point in the B2 cell. So it is again a formula equal to yp, which is b1, plus h, which is 0.1, times, okay, and it is this way. Sorry, why isn't it? Oh, I have clicked on the wrong operator. Okay, so this is this, and it will be e1 square because it is x square, so it is e1 square. What is happening? E1 square, yeah, plus 3 times b1 square, y square, so it is b1 square. Okay, and I come down, it is b1 times b1, a1 times b1. Okay, and I come up, bracket closed, and enter. Fine. The answer is 2.65. Up to 3 significant figures, it is 2.65. We have to give the answer up to 3 significant figures. So I'm not changing the settings. Let me take the answer. It is 2.65. Okay. So this is the support. Is question. It is x and y. When x equal to 1, y is equal to 2. And when x equal to 1.1, it is x equal to 2, y is equal to 2.65. Okay. So, and it is containing 2 marks. Okay. So, at most what you can write is, in place of this, you can write xc is equal to xp plus 0.1 in place of this, because it is containing 2 marks. So if you want, you can give these two equations, and to show that which two formulas you have used. This is equal to yp plus 0.1 times, it is xp square plus 3 times yp square over xp times yp, where xp is equal to 1 and yp is equal to 2. Okay, you can write this and you get this. This will be the answer. Okay. So coming to subpart B, by solving the differential equation, show that y is equal to this. We have got the approximate value of y when x equal to 1.1. Now they are asking us to solve this differential equation. And we know several methods, at least 3 methods we know of solving differential equations. One of them is, the first one is separation of variables. But over here, we are seeing that we cannot separate the variables, because I can separate the terms. One will be x square over y, xy, and the second term will be 3y square over xy. We cannot separate the x and y totally. So we cannot use this method. The second method, another method, is the integrating factor method, which is of the form which is used when, let me write it over here. It is maybe dy by dx plus py is equal to q. If you have a differential equation of this form, you can use the integrating factor method. But over here, if I just separate the terms, this is the subpart B. So if I just separate the terms, what happens? What happens is x squared over xy plus 3y square over xy, which is equal to x over y plus 3y over x. And this, therefore, I can say that dy by dx is a function of y over x, because x over y can be written as 1 over y over x. So it is a function of y over x. And whenever the dy by dx expression is a function of y over x, it is known as a homogeneous differential equation. Therefore, it is a homogeneous differential equation. Okay. Therefore, we can solve it using the substitution y equal to v times x. Okay. Whenever you see that the dy by dx is a function of y over x, it shows that it is a homogeneous differential equation. And in order to solve homogeneous differential equations, you can take this substitution y equal to vx. Okay. So therefore, y over x is equal to phi. Okay. And if I differentiate both sides with respect to x, what happens? It is dy by dx is equal to, I'll be using the product rule for the right hand side. First of all, I am differentiating the x, so it is just v, because derivative of x with respect to x is of course equal to 1. And v is also a function of x, it is not a number. So the second one will be, that is why we are using the product rule. If v was a number, then it would have been the coefficient, we wouldn't have needed the product rule. So this is x and dv by dx. Okay. So we are having this expression for dy by dx, as well as we are having this expression. Okay, dy by dx is equal to x over y plus 3y over x. So I can equate them. This may be 1 and this may be 2. Combining, I can write combining 1 and 2. We get x over y, and you see y over x is equal to phi. So x over y will be 1 over v. So it is 1 over v plus y over x is v. So it is 3v is equal to this part, phi plus x dv by dx. Okay, and this is, I can take phi to this side, and what happens? It is 3v minus v, or I can subtract v from both the sides. It's the same. Actually, this is the operation that we are doing. We are subtracting v from both the sides. So it is 1 over v plus 2v. 3v minus v is 2v is equal to x dv by dx. And this is, I'm just going horizontally for some steps because I don't have sufficient space, I feel. So this is v, and it is 1 plus 2v square is equal to x dv by dx. And now I can separate the variables. I can write this as, and integrate both the sides. Dx by x, integral of 1 over x with respect to x, the left hand side, and the right hand side is equal to v over 1 plus 2v square dv. Okay, now we have separated the variables, so now we can integrate. The left hand side is very easy. It is ln of x, and because x is greater than 0, y is greater than 0, I'm not taking the absolute value, I'm just taking the bracket. Okay, otherwise you should be taking the absolute value, because the integral answer is ln of the absolute value of x. You cannot have a negative number as the argument of x, argument of the ln function. Okay, so, and for the right hand side, what is it? So let t be equal to 1 plus 2v square. Therefore dt by dv is equal to 4v, or dv is equal to dt over 4v. Okay, so for the right hand side, I'm writing v, and the denominator is 1 plus 2v square is t, so I'm writing t, and it is dt over 4v. So these two will be getting cancelled, so I am having, and I can take out the 1 over 4 outside the integral sign, so it is 1 over t dt. So this is ln of x plus equal to 1 over 4, sorry, 1 over 4 ln of t, and okay, first of all, let me write t, and of course there is the plus c. Don't forget the plus c. So this is 1 over 4. I will be substituting the expression for t, which is 1 plus 2v square. Okay. So it is ln of 1 plus 2v square. V square, whatever may be the value of v square is a positive number. 2 times v square will be positive, plus 1 is positive. So I'm not taking the absolute value. I'm taking the bracket. Okay. So it is 1 plus 2v square plus c. And what is v? Now I am substituting the expression for v. V was equal to y over x. Okay, so this is equal to, and sorry, this is 4. Once I have written 3, now I have written 2, it is 4. So 1/4 ln of, it is 1 plus 2, v is y over x, so it is y square over x square plus c. And now we have to find the value of c. And what is given to us? We know that y is having a value of 2 when x is equal to 1. So we'll be substituting these values. Okay. So this is ln of 1 is equal to 1 over 4 ln of 1 plus 2 times 2 square over 1 square plus c. So this is ln of 1 is equal to 0. So this is 0, and this one is 1 over 4. 2 times 2 square is 2 square is 4, 4 times 2 is 8, 8 plus 1 is 9. So it is ln of 9. Okay, ln of 9 plus c. And so this is equal to, therefore, c is equal to negative 1 over 4 ln of 9. Now I can write in place of c, I will be writing this. So it is ln of x. Since c is a negative number, so I can bring c to this side on the left hand side. So I am taking ln of x plus ln of 9 to the power of 1/4. No, I'm not having 9 to the power of 1/4. So let me do one thing. Let me not take 9 to the power of 1/4. Let me keep the 1/4 in front. Okay. Because I have to come to this form. So I don't want to have 9 to the power of 1/4. Let me keep this as it is. Okay. Is equal to, so I have taken the c to that side. It should be this one. This one. 1 over 4 ln of 1 plus 2y square over x square. Okay. And I can multiply the entire equation by 4. So this gives us 4 ln of x plus ln of 9 is equal to ln of 1 plus 2y square over x square. And this can be now taken as x to the power of 4 because I am having x to the power of 4. Therefore, I can have the courage of making that as x to the power of 4, and I can combine these two terms. So it will be ln of, it is ln of 9 x to the power of 4 is equal to ln of 1 plus 2y square over x square. I'm really not sure whether you are being able to see that part. So I'm writing it once more over here. Ln of 9x to the power of 4 is equal to ln of 1 plus 2 y square over x square. And now I can safely take the arguments of ln from both the sides, and I have 9x to the power of 4 is equal to 1 plus 2 y square over x square. So it is 2y square over x square is equal to 9x to the power of 4 minus 1. And so this is 2y square is equal to x square times 9x to the power of 4 minus 1. Okay. And this is y square is equal to x square and 9x to the power of 4 minus 1 over 2. And I'll be taking the square root of both the sides. So it is x square, square root of x square is x, and it is 9x to the power of 4 minus 1 over 2. Okay. I have taken the positive square root because since y is greater than 0. That is why I have taken the positive square root, because whenever you are square rooting, you'll be having two signs, okay? Plus, minus. I have taken only the positive square root because y is greater than 0 given. Okay, x is greater than 0 and y is greater than 0, and you have to show, so it is shown. We have solved the differential equation, and it is subpart C is saying find the value of y when x equal to 1.1. Of course, now we will be using the this expression for y. Okay, so this is, let me write the subpart C's answer over here. Y is equal to x, and it is containing just a single mark. Okay, so 9x to the power of 4 minus 1 over 2 when x equal to 1.1, y is equal to, we have to use the calculator, definitely. It is, okay, we have to go to the calculator page, and it is, what is it? X times square root of 9x to the power of 4. X is 1.1, right? So it is 1.1 times square root of, and yes, it is 9 times x to the power of 4. That means 1.1 to the power of 4. And what is it? Minus 1 over 2. So minus 1 over 2. Okay. It is 2.714 and all up to 3 significant figures we can take it as 2.71. Okay. So it is 2.71 correct to 3 significant figures. And you see, using the Euler's method, we had found the value of y as 2.65 when x value was equal to 1.1. Okay. Now coming to subpart D, with reference to the concavity of the graph. Concavity is related to the second derivative. Okay. Concavity of the graph of y equal to x times square root of 9x to the power of 4 minus 1 over 2 for x greater than or equal to 1 but is less than or equal to 1.1. Explain why the value of y found in the subpart C, this one, that is 2.71, is greater than the approximate value of y found in part A, that is 2.65. Okay, so first of all, let us see whether what happens is, okay, let me take the answer for this over here. Like for Euler's method, you have, suppose you are having a curve like this, okay, and we have started with x equal to 1. In the Euler's method, they give you one initial value of x, and they ask you for another approximate y value when x is having another value, okay. But they give you the approximate x and y, not the approximate, the exact x and y value for 1 point, okay. So maybe this is the initial point, okay, and dy by dx function is the gradient function, so it is related to the tangent. So over here, if I draw a tangent, it will not be a very accurate tangent, but let me draw a line over here. Maybe this is the tangent at this point, okay. If we use the Euler's method, suppose we are asked to find the x value. This is the graph, and we are given the x and y value for this point x1, and we are required to get the x value, the y value, approximate y value when x is equal to x2, okay. So when the graph is concave up, this is concave up graph, and for Euler's function we will be having the tangent at this x equal to x1 point, and we will be moving along this tangent line. We will be just taking the step length, and we will be increasing the x value and moving along the tangent line. So you are seeing, as we move towards the right, as the difference between the given x value and the x value for which we want to find the y value is getting large, the difference is getting large, the difference between the exact y value and the y approximate value that we will be getting from the Euler's expression is also becoming more and more. Okay, it is becoming more because the tangent is going in this direction and the graph is going in this direction. Okay, so the difference in the two values is just increasing, and the accurate y value will be more than the approximate y value if the concavity is positive. That means the graph is concave up. But if the graph is this is the case in our this is what we are having, because we are seeing from the Euler's method we are getting a value which is less than the accurate answer. Okay, so we know that the graph should be concave up, because if the graph is concave down, then what happens is suppose the graph is this way, it is concave down, and you are drawing the, maybe this is the tangent. You see, this is x1, and maybe you want to find the value of y when x is equal to x2. Now you see you are again moving along the tangent. Now you see the approximate y value that you will be getting for x2, x equal to x2, will be more than the accurate y value. Okay, so because the value that we have got through Euler's method is less than the accurate value, we can say that the graph is concave up. But let's check, because we are having the calculator, we can check the authenticity of our reasoning. Okay, so but for that we have to get the graph. We can skip the graph. We can save this expression in the form of function, and then we can graph the second derivative. That can also be done. So the expression is x times, and what is it? Square root of 9x squared to the power of 4 minus 1. So it is x times square root of, oh, I can see you from here, 9 times x to the power of 4 minus 1 over 2. Okay, and I want to store, you see over here there is the store thing in red, so I have to press this, and let me take it as, say, what should I be taking? I can take h, say h of x. It is, why didn't it, h and x. Okay, so enter. It is done. Let me just check. If I press h and it is, let me, I'm just taking 0 just to see whether it's working. What will be the value of h of 0? Because x is 0, the value of h of 0 has to be 0. Let's see what answer does it get. It is 0. Okay. So we have stored this expression correctly in the h of x expression, h of x function rather. So now I can go to the graph page. I go to the graph page, and over here I need to take the second derivative. So I go to this over here, and it is the second derivative, and it is with respect to x, of course. And I come over here, and you see over here there is this h. So I'm taking h. Okay, and fine, and I'll be drawing the graph of the second derivative of h of x. Okay, that is fine, very good. But what is the range of values that x is having? Between 1 and 1.1. So I can see how I can change the window settings. It is between 1 and this is 1.1, and okay. There's nothing. What has happened? Oh, it is over here. So between 1 and 1.1, you see it is, I don't know what is the value. Let me take between, let me again go to the Windows settings, and let me take the Y min, and okay, they have taken the, okay, it is Y min. You can see this, let me take this 1.1. This should be 1.1. Sorry. Or this is 1.1, and this should be 1. And I can take this as 3, and I can take this as 20. Okay. Now you see the second derivative, it is totally positive. In this range, 1x is greater than or equal to 1, but is less than or equal to 1.1. It is totally positive. Okay. So what is the value at, if I go to graph trace, and graph trace, and if I take 1.1, what is the value? I'm entering 1, and it is 12.375. Okay. So let me just write. It is containing 2 marks. Okay. So d2 y by dx square when x is between 1 to 1.1 is greater than 0. Okay, and it is containing 2 marks. So we have explained this, and if you want, you can just show the graph. It is like this, maybe. It just draw a rough sketch. And it starts from y, it is 1 and 12.7375. So maybe this is 1. I'm taking from 1 to this is 12.375. I'm taking up to, or let me write 12.375. Okay. And what is the value when x equal to 1.1? It is 13.7669. Okay. So let this be 1.1, and this is 13 point, what was it? 13.7669. So maybe this is just a rough sketch. Okay. 13.7669 most probably. Let me just check once more. 13.7669. So it will be going there. So it is like this, more or less like this. Okay. So this is the d2y by dx square graph. So you are seeing that it is greater than 0. And if the second derivative is greater than 0, that means the curve is concave up, Hence, the approximate value of y is less than the accurate value. Okay, so it is containing 2 marks and we have given sufficient explanation. Okay, graph of y equal to x times square root of 9x to the power of 4 minus 1 over 2 for x greater than root 3 over 3, that is 1 over root 3. You can write 1 over root 3 as well, and but is less than 1, has a point of inflection at the point P. So part E's question is, by sketching the graph of an appropriate derivative of y, determine the x coordinate of P. And you know the inflection point, wherever you are having the inflection point, the second derivative should be equal to 0. Okay, so fine. Now we have already graphed the second derivative of this. So let me just write it over here. Okay. For a point of inflection, the d2 y by dx square should be equal to 0, and not only that, it should be changing the sign. The second derivative should be changing the sign around that point. Okay. So let us go to the graph once more, and this time I'll be changing the settings and I'll be taking the x values from root 3 over 3 and taking 1 over root 3 and 1. Okay. So this is the x square, the second derivatives graph, and I am going to the menu and Windows settings, and I will be taking the x min as 1 divided by square root of 3. What happened? 1 divided by square root of 3. Okay. And the maximum value is 1. What am I doing? Okay. X min is 1 divided by square root of 3, and the x max is 1. And let me take the y min as because I need the 0, so I can take -1. Sorry, -1, and let this remain as 20, or I can just take it as 10. Okay. Error. Why is it error? Giving error. That part is not taking. So okay, then I have to take root 3, and let me put another bracket over here and over here. Bracket is starting and divided by 3. Okay, and does it work now? Yeah. Okay, it's working. And you see, this is the 0, and around this point, the sign of the second derivative is changing from negative to positive. So the sign is changing. This is important. Just when the second derivative is equal to 0, doesn't say that, doesn't justify that value of x as the point of inflection. The sign of the second derivative should also change around that point. Okay, around that x value. So let us get the 0. Okay, and of course, I'll be taking only the x coordinate because this is a very small number. So they haven't given this to be equal to 0, but it is really a small number. So I am taking the x coordinate as 0.656. By sketching the graph, I have to draw this one. It will be a rough sketch. Obviously, it is containing just 2 marks. This is 0.656, and the graph will be going this way. This is the second derivative, d2y by dx square graph. Okay, so by sketching the graph for this is the determine the x coordinate of the point P. So this is point P, and x coordinate of P, of point P, is 0.656 correct to 3 significant figures. Okay, coming to the last part of this question. It can be shown that d2y over dx square is equal to negative x to the power of 4 plus x square y square plus 6 times y to the power of 4 whole divided by x square y cubed, where x is greater than 0 and y is greater than 0. So part F's question is, use this expression for d2y over dx square to show that the point P lies on the straight line y equal to mx, where the exact value of m is to be determined. It is containing 6 marks. So P is the point of inflection, hence the d2 by y by dx square has to be equal to 0. Okay, so if since P is the point of inflection, therefore d2y by dx square is equal to 0. Implies minus x to the power of 4 plus x square y square. I did not give this is x and this is y. Okay. Plus 6y to the power of 4 over x square y square is equal to 0, or minus whenever you have a fraction equal to 0, then safely you can take the numerator to be equal to 0, of course, because if you multiply both sides with x square y square, you get the numerator is equal to 0. X square y square times 0 will be 0. Plus 6y to the power of 4 is equal to 0. And now they are asking us to find the exact value of m. And P is lying on the straight line, and if P is lying on the straight line, we have to find the m value for that case. So what is m in terms of y and x? Because this equation is not containing any m, but we have to find the value of m. Therefore, y is equal to mx implies m is equal to y over x. Okay, because I have to introduce m in this equation. Otherwise, I'll not be getting the value. I don't have any other equation which I can use. So I have to use this equation. And m is equal to y over x. So I want to express this equation in form of either x over y or y over x. Okay. So what I can do is, this is having x to the power of 4. So I can divide the entire equation by y to the power of 4. Because this is the highest power of y. So let me divide by, so it will be x over y whole to the power of 4, and x over y will be equal to 1 over n. Okay, so I'm dividing the entire equation by y to the power of 4. Plus x square y square over y to the power of 4, and plus 6y to the power of 4 over y to the power of 4 is equal to 0. 0 divided by y to the power of 4 is 0. So this is minus x over y to the power of 4 plus this will be getting cancelled. So it is x over y to the power of 2 plus 6 is equal to 0. And this is negative x over y is 1 over m. So it is negative 1 over m to the power of 4. 1 to the power of 4 is of course 1. So it is 1 over m to the power of 4 plus 1 over m square plus 6 is equal to 0. So I can take m to the power of 4 as the common denominator, and it is negative 1 plus m square plus 6m to the power of 4 is equal to 0. And I am multiplying both the sides by m to the power of 4 so that I get 6m to the power of 4 plus m square minus 1 is equal to 0. Okay? And I can tell this is a quartic equation. I do not know how to solve it, but I can change it to a quadratic equation by taking m square equal to, say, t, okay, or t. So let m square equal to t. Then what happens? So m to the power of 4 will be equal to t square. So 6t square plus t minus 1 is equal to 0. Okay, so now it has got changed to a quadratic equation, and I can write it as 6t square. I can take plus 3t minus 2t minus 1 is equal to 0. So this is 3t and 2t plus 1 minus, it is 1, 2t plus 1 is equal to 0. So this is 3t minus 1 and 2t plus 1 equal to 0, implies t equal to negative half or t equal to 1 over 3. Okay, therefore t was what? M square. M square is equal to negative half, which is absurd, cannot be negative. And therefore m square is equal to 1/3. So m should be equal to plus minus 1 over root 3. Okay, and you see the question shows that, gives you this hint that m will be having a single value, exact value of m. So you are getting x as m as plus minus 1 over root 3. Don't stop over here because it is not the correct answer. M will be having a single value. You have to reject one of the values. How do you reject one of the values? They have said both x is greater than 0 and y is greater than 0. In case you can graph this, you will be seeing that you are having the positive gradient. You are having the calculator with you. So you can use the calculator to graph this expression. It is the h of x was the expression. Okay. Or I can take, this is, where is h? This is h. Yeah. You will be seeing it is in bold. That will be showing that you have taken the correct variable. If you just type the h and it is not in bold, then you should be knowing that there's something wrong somewhere. So it is better to use the variables. Okay, h of x. Okay, so this is the graph, and it is from, I can take it from root 3 over 3 to 1. Let's see. Okay, it is root 3 divided by 3, and this one is 1. Okay, and let's see what happens. Okay, So this is the graph between root 3 over 3 and 1. And so you are seeing the y values are all positive, and as x value is increasing, the y value is also increasing. So this means the gradient will be positive number. Okay. So since x is greater than 0, y is greater than 0, I am not giving the graph. You can give a rough sketch also of the graph that we have just now seen. Therefore, m is equal to 1 over root 3. You can get the graph that will also be acting as the reason for your answer. Okay. So this is the answer for the part F. They have asked for the exact value, so we have to give 1 over root 3. Don't get the decimal equivalent. Okay. So this is all for question number 12. We have completed answering this whole paper. Thank you for staying with me till the end. In our next session, we'll be starting with another paper, the paper 3 actually, time zone 2. And in case you are liking my explanation, please to give this video a like, and please to share this video with your friends so that even they can get benefited by watching my videos. And in case you have not subscribed to my YouTube channel, please subscribe to my YouTube channel. It will be motivating me to make more math videos for you. I'll be knowing that I'm being able to help you. So till our next session, bye.